Lately, we got a gander at a couple of enchanting pictures as we peer back close to the start of all that the James Webb Space Telescope has as of late disclosed. A revelation that challenges the foundations of our understanding has enchanted the premium of cosmologists and scientists, demonstrating a perhaps legendary occasion fit for changing the universe from our perspective. The importance of this finding is critical, raising inquiries regarding the actual reason of our affected presence. The request arises, might this disclosure sooner or later lead to the uttermost furthest reaches of all that we be aware? Is the universe close the actual edge of an uncommon occasion past our ongoing getting it? Go along with us as we dive into the most recent revelation from the James Webb Telescope and investigate its capability to reshape how we could decipher the universe. Our cycle starts with an evaluation of the recognizable universe, or rather, a window into the enormous spread past it. The conspicuous universe envelopes everything that could be recognized, measure, and analyze with our telescopes and space missions. It is a combination of star frameworks and divine bodies noticeable to us, tending to just an immaterial part of the entire universe, a little piece of a gigantic enigma that individuals attempt to survey and understand. No matter what our headways, the general size and kind of the universe stay a secret. The breadth of the apparent universe is assessed to be roughly 93 billion light-years. This shocking figure results from different components, including the distance light can go in one Earth year. The age of the universe, assessed at 13.8, a long time since the enormous detonation, derives that the detectable universe expands 13.8 billion light-years toward every way from Earth, providing it with a width of around 93 billion light-years. In any case, Hubble's regulation shows that space has been reaching out since the huge explosion, prompting the recognizable universe additionally growing. Energy gauges recommend that items sending light billions of years prior from a distance of 13.8 billion light-years are presently around 46 billion light-years away. This development suggests that the unmistakable universe reaches out more than 46 billion light-years toward every way from Earth. The massive development started by serious areas of strength for billions of years prior has driven not exclusively to the universe extending yet additionally speeding up. Complex powers, like baffling dim energy, appear to be driving this speed increase, extending the universe's limits further separated. As the universe extended, gravitational powers organized particles, prompting emotional developments like stars, worlds, and planets, including our own Earth. Notwithstanding the enormity of the universe, mechanical headways have permitted individuals to investigate a greater amount of it persistently. Explicit telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, have empowered the perception of far-off stars and systems, making these marvels more available to the overall population. In looking at the limitless region, it is entrancing to take note of that even inside our broad planetary framework, the universe shows up particularly void. The nearest star, whenever scaled back to the size of a quarter, would in any case be around 2 soccer fields away. This endlessness expands just inside our smooth-way cosmic system, one of billions in the noticeable universe, offering us a short look into the tremendousness of galactic size. As we proceed with our examination, the new disclosure by the James Webb Space Telescope adds one more layer important to how we could decipher the universe, inciting further requests about the idea of our existence and the potential for uncommon occasions on a fabulous scale. You might be interested about why we can't notice the sum of the universe. There are a few purposes behind this limit. Regardless of light being the quickest object in the universe, it actually requires investment to go through space. In this manner, when we notice far-off objects, we are basically investigating the past. The farther an item is, the more its light has ventured out to contact us, making a kind of infinite time machine that disentangles the historical backdrop of our universe. Another fundamental part having an effect on everything is the extension of the universe. Envision the outer layer of an inflatable shrouded in spots. As the inflatable blows up, the specks move separated. Likewise, universes float away as the texture of room grows. This extension brings about a peculiarity known as redshift, where the light produced by far-off objects goes through modification and frequencies are extended toward longer, ruddy circumstances. A few heavenly bodies eventually outperform a basic distance, arriving at the infinite skyline, where their light is excessively far away to reach us as a result of the continuous improvement of the universe. Taking into account these two fundamental variables, the movement season of light and the extension of the universe, it's not shocking that we haven't noticed the whole universe yet, even with the most progressive telescopes and innovation. Our vision stays obliged by the basic elements of the universe. We ought to dig further into these ideas. The size of the universe is dynamite, estimated in light years to exhibit the distance light goes in a year. Our smooth way goes around 100,000 light years. Indeed, even inside our universe, the closest star to our Sun, Proxima Centauri, is generally 4.24 light years away. At the point when we investigate space, we can notice cosmic systems billions or millions of light years away, permitting us a short look into the early history of the universe. The secret of the universe's edge has captivated individuals from different fields. While conclusive responses stay subtle, three basic theories have arisen. The first recommends that the universe is limitless and huge, with no apparent endpoint, broadening unendingly every which way. The second proposes a limited universe without an undeniable edge, similar to a huge circular or bended space. In this situation, voyaging unendingly toward any path would at last take one back to the beginning stage, similar as circumnavigating the Earth. The third speculation, the multiverse hypothesis, presents the likelihood that our world is only one among many, each with particular actual regulations and properties. These universes could work freely or be interconnected, shaping a huge and mind-boggling multiverse. Investigating these theories lights both logical and philosophical premium. The idea of an endless universe challenges our view of room and its boundlessness, while a limited universe without an edge difficulties our thoughts of cutoff points and congruity, recommending the potential for repeating designs inside the texture of room. The multiverse speculation, with its equal universes, opens up potential outcomes past our ongoing comprehension, showing domains boundlessly not the same as our own. Nonetheless, it is critical to take note of that these thoughts stay theoretical and elusive, anticipating further examination. Investigating the universe's edge presents critical difficulties, making it hard to approve or excuse existing hypotheses definitively. The boundlessness of enormous space, joined with the restrictions of our observational instruments and innovation, makes obstructions in disentangling the secrets encompassing the universe's limits. Regardless, in the midst of this limitless vulnerability, the James Webb Space Telescope arises as an encouraging sign, promising to reveal insight into the frustrating beginnings of our universe. The JWST stands apart as a game-evolving device, offering unrivaled accuracy in reviewing the universe. This wonderful instrument can possibly divulge the baffling history of our universe, giving bits of knowledge a long ways past recently imagined ideas. As a mechanical wonder, the JWST has as of late made pivotal disclosures, especially in the examination of the universe's edge. One of the critical discoveries incorporates the idea of 6 monstrous cosmic systems going back between 500 million and 700 million years after the enormous detonation, distributed in the diary Nature. This examination challenges laid-out speculations about the beginnings and advancement of worlds in the early universe. Shockingly, these old systems show estimates a lot bigger than anticipated for their age, challenging expectations and reshaping the story of grandiose turn of events. As opposed to beginning suppositions of noticing little adolescent systems, stargazers were surprised to find these monster cosmic elements. The development of these antiquated systems is bewildering, like our 13-billion-year-old smooth way. The stars inside these enormous behemoths have a tremendous all-out mass, for certain cosmic systems possibly having a heavenly mass up to 100 billion times that of our Sun. The JWST's unmatched capacity to divulge the universe's mysteries lies in its utilization of infrared light, undetectable to the natural eye. This capacity permits the telescope to recognize faint emanations from old stars and worlds, uncovering grandiose remainders that have persevered for billions of years. Filling in as a time machine, the JWST sends our vision back through time, offering priceless experiences into the universe as it existed around 13.5, quite a while back. The new disclosure of huge systems, named universe breakers, has altered how we might interpret astronomical development. These unforeseen discoveries challenge recently held models, investigating the customary conviction that universes started little and developed consistently over the long haul. The James Webb Space Telescope, with its high-goal pictures and spectroscopic procedures, had a significant impact in disentangling the secrets of these colossal worlds, outperforming all assumptions. The chance of extremely enormous dark openings sneaking inside these worlds adds one more layer of secret to the grandiose texture. In any event, while considering just a small portion of the information, the known mass of stars in the universe may now at last rely upon a shocking on different occasions more than past evaluations. This disclosure prompts a key reassessment of how we grasp inestimable mass and design. It provokes existing models and urges space experts to refine their hypotheses about cosmic system development and advancement. As we dive further into the information given by the James Webb Space Telescope, we uncover new layers of intricacy in the universe's set of experiences. The investigation of these old worlds isn't simply a scholastic activity. It has significant ramifications for how we might interpret the universe's course of events. The presence of such monstrous designs when the universe was still generally youthful recommends that the cycles of cosmic system development were surprisingly fast and complex. This difficulties the customary view that worlds developed steadily north of billions of years. Additionally, the JWST's capacity to notice the universe in infrared permits researchers to look through grandiose residue mists, uncovering stowed-away stars and heavenly nurseries that were recently clouded. This capacity upgrades how we might interpret star development and the circumstances in the early universe, giving a more clear image of how the main systems rose up out of early-stage tumult. As we break down these disclosures, we are likewise helped to remember the immense questions that remain. Each new tracking down brings up unexpected issues about dull matter, dim energy, and the principal powers forming the universe. How do these components interface with the apparent matter we can notice? Which job do they play in the elements of cosmic systems and the enormous scope construction of the universe? Notwithstanding these logical requests, the disclosures made by the James Webb Space Telescope light a feeling of marvel and interest in our spot in the universe. They welcome us to examine the idea of presence and the chance of life past our planet. In the event that such gigantic systems could frame so from the get-go in the universe's set of experiences, what could that suggest about the potential for livable universes in the immense spread of room? As we push ahead, the James Webb Space Telescope will keep on being at the front of cosmic examination, directing us toward new bits of knowledge and leap forwards. It addresses a critical jump in our observational capacities, permitting us to investigate districts of the universe that were once remembered to be past our range. The excursion of understanding our universe is continuous, loaded up with difficulties and disclosures. With every disclosure, we are uncovering the historical backdrop of systems as well as sorting out the many-sided puzzle of enormous development. As we stand near the very edge of new disclosures, the fate of cosmology looks encouraging, energized by the information and experiences from the James Webb Space Telescope. In synopsis, the disclosures from the JWST are reshaping how we might interpret the universe and testing long-held suspicions about astronomical advancement. These revelations improve our insight as well as rouse a more profound appreciation for the secrets that actually lie ahead. As we keep on investigating the endlessness of room, we stay focused on unwinding its mysteries and growing our cognizance of the universe we occupy.